Good morning, Year 4, and welcome to your last maths lesson of this week. Today we are going to be counting in tenths. So, I have your daily fluency questions here. This should take you no more than around 3 minutes. So, pause the video now and work on these. Don't forget to write them down underneath your subheading and your title today. Okay, pause the video now and have a go. How did you get on? Did you work out 35 multiplied by 9 using the short written multiplication method? You will have got 315 as your answer. Number 2 is round 347 to the nearest 10. Well, if we know we are rounding to the nearest 10, we can look at my tens column, which is my 4, representing 40. Now, because I've got 47, I am going to be rounding up to a multiple of 10, which would be 50. So my answer is 350. Number 3, what is the area of this shape? Give your answer in squares. Well, we can see we have got rows of 6 and columns of 3. 6 multiplied by 3 is 18 squares. Alternatively, you could have counted the squares to work out the answer. I have another retrieval for you here today, which is going to help you with today's lesson. So, can you pause the video now, work out which fractions of the cubes are of each colour and which fractions that you have found are unit and non-unit fractions. Pause the video here and have a go. Okay, well, first of all, we can work out our denominator by working out how many cubes we have altogether. And if we count the cubes, we will notice we have got 10 cubes altogether. So the denominator for each of my fractions for the coloured cubes is going to be 10. And I can count my yellow cubes and work out I have got 5 yellow cubes. So 5 of the 10 yellow cubes are yellow. Or 5 out of the 10 cubes are yellow. I can see that I've got 4 red cubes, so 4 of the 10 cubes are red, and 1 of the 10 cubes are green. Now, do you remember what a unit fraction is? That's right, a unit fraction has a numerator of 1. And we can see here that my green fraction is a unit fraction as it has a numerator of 1. So which fractions are non-unit fractions? My yellow and my red fractions are non-unit fractions. Why? Fantastic, they have a numerator of a number greater than 1. Fantastic, that's going to help you for our lesson today. Now here I have a tens frame showing some counters. Now I can see that I've got some red counters and I want to find out what is the fraction of my yellow counters. Well, how many red counters do I have? I have 10, so I know that my denominator will be 10. And how many yellow counters do I have? None. So I know that my fraction would be 0 because I don't have any yellow counters here. Now, this time I have got some yellow counters. How many do I have? Well, I can see I have 1 yellow counter and 10 counters altogether. So my fraction is 1 over 10. 1 out of 10 counters are yellow. I can show this on a bar model if I split my model into 10 groups. Why would I split my model into 10 groups? That's right, because I have 10 counters, I have split it into 10 parts because that's what my denominator shows. And I can show here that 1 out of my 10 parts are shaded in yellow, showing me my fraction 1/10. Now here, this time, I have 2 counters that are yellow. So this time my fraction would be 2 out of 10. And I could show it in my bar model here. If I increase this, what is my fraction of yellow counters now? That's right, 3 out of 10 counters are yellow. 3/10 are yellow. Now, how many boxes would be shaded in on my bar model this time? 3, fantastic. And I can also show one more example here. What would my fraction be this time? Ah, yes, 6/10. No, why not? That's right, because we're looking at the yellow counters. So we can see we have 4 yellow counters, 10 altogether, and we can show this on my bar model like so. This time, I want to find out what fraction of the counters are yellow. How many counters do we have altogether this time? And how many counters are coloured in yellow? So, 10 out of my 10 counters are coloured in yellow. Can you think of another way to represent this fraction? That's right, 1, because 1 whole tens frame has been covered. And we can show my bar model here because my bar model has been split into 10 and each of these 10 are shaded in because that shows my fraction of counters that are yellow. This time, what fraction of my counters are yellow? Well done, 9/10. So 9 parts of my bar model will be shaded. How about this one? That's right, I can see that I've got 8 yellow counters shaded in and 2 remaining. So I have 8 out of 10, so 8 counters, and show that on my bar model here by shading in 8 of them. This time, how many do I have? What is my fraction which are showing how many yellow counters I have? Fantastic, 7/10. Now, what is the fraction of my red counters then? That's right, it would be 3/10, wouldn't it? Because I have 3 red counters out of 10 remaining. Okay, so now it's your turn to have a go at questions 1 to 3 on the worksheet. So pause the video now and have a go at those, please. Fantastic work so far, Year 4. So far we have looked at 2 ways of representing our fractions. We have looked at my tens frame on the left and the bar model on the right. We're going to look at the number line now to help us to represent these fractions. Now I can see that I'm still looking at tenths, so I'm going to split my number line into 10 different parts. Now, first of all, I can see that I have no counters in my tens frame, I have nothing shaded in my bar model, and I have nothing represented on my number line, so my fraction is 0. If I added 1 counter here, I could add 1 on my bar model, I could make the fraction 1/10. And I can see that this would be pointed to my first line on my number line because that's my first part. This time I have got 2/10. So I have shaded in 2 sections of my bar model, and I have also identified where that is on my number line. So now we have got 1 part, 2 parts, 2/10. We can continue counting up and make 3 parts and show that on my number line as 3/10, 4/10, 5/10, 6/10, 7/10, 8/10, 9/10, and 10/10. And you can see here that 10/10 is the same as 1. And you can see on my number line, my 10 parts gradually get bigger as I count in my tenths. But it could also be shown as 1. I would like you to now have a go at question 4 on the worksheet, please. So pause the video here and have a go. Okay, let's look at the next step. So we have now looking at how we can use a bar model to find the fraction, and also how we can use the number line. Now I am going to make this number line smaller and also see if I can how I have represented this. So I can see that for each of my bar models, it corresponds to the fraction. So I can see I've got 10 parts, 1 is shaded, so my fraction is 1/10. I can see here that I've got 10 parts, 6 are shaded yellow, so my fraction is 6/10. We're going to see how we can count past 10/10 and what that fraction would be. So here I've made a bar model which is 1 more than the one that I've made here. And I'm starting to think, well, what fraction have I made? And I can see that I've got 1 bar model which is full, which shows 10, and then I've got 1 here, which shows 11. So I have made 11/10. I could increase this by 1 and add 1 extra one. And this time I can see that I've got yellow parts that are shaded in. 12 yellow parts that are shaded in. So that would be 12/10. And I could increase this and show 13, 14, 15, 16, 17, 18 and 19/10. Now, what would happen if I added on this final yellow part of my bar model and I shaded that in? What would my fraction be then? Pause the video and have a think. How did you do? Did you work out it would be 20/10? What's that the same as? If 10/10 is the same as 1, what might be 20/10 be the same as? How many bar models have I filled? That's right, it would be the same as 2. So here we've worked out how we can count in tenths, and when we get to 10/10, which is 1, how we can continue counting up so we can get 20/10, which is 2. And we can see how much bigger my bar model gets each time we add 1. Well done. Now is your turn to have a go at the rest of the questions on the worksheet. Pause the video and resume to this video when you've done that. Okay, let's have a look at some reasoning and problem solving questions. So I've got my first reasoning question here, and Amir is using counters to show tenths, just like we have in today's lesson. But he has a theory, and he says that, year 4, if I take away one of my counters, I will have 4/10 altogether. Is he correct? And explain how you know. Well, we need to think, if he takes away one counter, then he's going to remove one counter. So his new chart would look like this. So he's now got 2 counters on here, and he's got 10 altogether. And I'm thinking, well, what would my fraction be? Well, I've got 10 altogether, so 10 would be my denominator, and I have got 2 counters, so I am showing 2/10. But Amir thinks he would have shown 4/10. So is he correct? I can see lots of you shaking your head. He's not correct, but we need to explain why. So he is incorrect, but why? Well, he's incorrect because what he needs to do is actually add another counter on here, because that would mean he'd have 4/10, wouldn't he? He'd have 4 counters, 10 altogether, so he'd have 4/10. And we know that if he takes one counter away, he will have 2/10, not 4/10. So we've correctly identified that Amir is correct, but we've explained how we know because we've used that word because. We've said what Amir has done wrong. He's took one away, so he'll only have 2 counters left. He'll have 2/10. And what he needs to do, he actually needs to add 1 counter if he wants 4/10 altogether. Okay, our next question is another reasoning question. It is another question that requires us to really explain why using that word because. So Ben and Charlie are looking at 2 statements, and there are 2 statements here, and statement A says 4/10 less than 12/10 is 18/10. Statement B says 2/10 less than 11/10 is 9/10. Which statement is true? And explain how you know. Pause the video and just have a think of this question, please. Okay, did you work out which statement was true? Don't worry if you didn't, because we're going to work through this together now. So 4/10 less than 12/10. Well, I'm working out 12/10 take away 4/10. Now, I know that 12 take away 4 is 8. So 4/10 less than 12/10 would be 8/10, not 18/10. So that is incorrect. So now we need to try and hope, fingers crossed, that statement B is correct so that we can say statement B is correct because. Now statement B says 2/10 less than 11/10 is 9/10. What is that the same as? What calculation are we doing? That's right, we're doing 11/10 subtract or take away 2/10. Now if we think 11 take away 2, well 11 take away 1 is 10, 10 take away 1 is 9. The denominator, the tenth, has not changed, so I have 9/10. And here it says that I should also have 9/10. So that one is the one that is correct. So we know that statement B is true. But why? How do we know? Well, we know that statement B is true because 11/10 is 2/10 more than 9/10. We could say that 11/10 subtract 2/10 equals 9/10. So it's true. Now it's your turn to have a go at the rest of the questions, so you need to make sure you're having a go at the problem-solving questions today. Have a lovely rest of your day, and I will see you in our next lesson. Have a fantastic weekend too. Bye, Year 4.